Hello there. You are made of atoms, but atoms are 99.99% empty space, which means you are almost entirely nothing. Have you ever wondered what existed before the Big Bang? Sure you have. But have you wondered, was there time? Was there space? Or was there truly nothing? How did the universe know how to make atoms? How did it know the exact temperature to cool to? The precise forces needed to hold protons and electrons together? And here's something that haunts physicists. If any of the fundamental forces, gravity, electromagnetism, the strong or weak nuclear force, had been even 1% different, atoms wouldn't exist. The universe would be formless energy forever. So why did everything align perfectly? Why are you made of carbon and not silicon? Why oxygen and not sulfur? The universe had options. It chose these, but we don't know why. And here's where it gets stranger. Those atoms were created from actual nothing. 13.8 billion years ago, there was no matter, no energy, no space, no time. And then, without cause, without reason, without warning, everything exploded into existence. The universe went from zero to infinity in less than a second, but it was too hot, too violent. Atoms tried to form and were immediately torn apart. For hundreds of thousands of years, no atom could survive. And yet, eventually, they did. Hydrogen appeared first, then helium, then, billions of years later, inside dying stars, carbon was born, oxygen, iron, all the elements that would one day become you. But here's the question no one can answer. Why? Why did the universe bother? Why atoms? Why not just nothing forever? Tonight, we're going to trace that impossible journey from absolute nothingness to the atoms that are listening to these words right now. And through it all, you'll drift deeper into sleep, carried by the ancient rhythm of creation itself. And the strangest question of all, are atoms still being created right now? Is the universe still building? Or did it stop 13 billion years ago? And let's begin at the very beginning. Before atoms, before time, before anything, the singularity. 13.8 billion years ago, the universe was smaller than a grain of sand. Actually, scratch that. It wasn't small the way we usually think about small. It wasn't a tiny marble floating in empty space. It was all of space. Everything. Compressed down. Here's the weird part. Every galaxy you've ever seen, every star, every atom in your body, all of it was squeezed into a point so tiny we can't even properly describe it. Infinitely dense, infinitely hot. And then it exploded. But not like a bomb going off in a room. Because there was no room. Space itself started expanding. The universe didn't blow up into anything. It created space as it went. It made room for itself. This is nearly impossible to picture. And that's okay. Your brain evolved to understand everyday things. Doors, trees, gravity. Not what happened before space existed. We're not wired for this. Nobody is. The first second. Now, let's zoom in. Way, way in. To moments so brief they barely count as time. At 1/10,000,000,000,000,000,000,000,000th of a second, scientists call this Planck time. The universe was hotter than we can even imagine. Hotter than anything we can create in a lab. Hotter than our math can handle. And here's the humbling part. We have no idea what was happening. Our best equations, they break down. They stop working. It's like hitting a wall. The smartest people alive, with the most powerful tools ever built. And we still can't see past that moment. But then, at 1/10,000,000,000,000,000th of a second, something called cosmic inflation kicked in. And this is where it gets truly bizarre. Inflation, the universe, doubles 100 times. In less time than it takes light to cross an atom's center, the universe doubled in size. Not once, 100 times. Double, 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 over and over. 100 doublings in a fraction of a fraction of a second. This isn't normal expansion. This is space itself, reality itself, stretching faster than light, which sounds impossible, right? Nothing can move faster than light. But here's the thing. Space isn't a thing. It's the fabric. that everything else sits on, and it can stretch however fast it wants. Why did this happen? Honestly, we don't know. Scientists have a theory about something called an inflaton field, but we've never actually found it. It's basically a fancy name for we're not sure. But inflation solved a puzzle. Before we knew about it, scientists were confused. Why does the universe look the same in every direction? Why is it so smooth and uniform? Inflation explained it. Everything we can see came from one tiny spot that inflated into everything. So of course, it looks uniform. It all came from the same place. The catch, we don't know what started inflation or what made it stop. We just know it happened. Because without it, the universe wouldn't look the way it does. The atoms in your body, the calcium in your bones, it was made inside a star that exploded before our sun even existed. That calcium floated through space for millions of years. Eventually, it became part of a huge cloud of gas and dust. That cloud collapsed and became our solar system. The calcium ended up in Earth's crust. It washed into the ocean. Ancient sea creatures absorbed it. Then other animals ate those creatures. And billions of years later, it's in you, in your bones, right now. The iron in your blood, the stuff that carries oxygen to every cell in your body that came from an exploding star too. A star died violently, and in that death, it created the iron that keeps you alive today. The oxygen you're breathing right this second, it was made inside a giant red star. That star fused lighter elements together to create oxygen. Then when the star got old, it puffed out its outer layers into space. That oxygen eventually became part of Earth's atmosphere. And now, with every breath, you're pulling atoms, made in stars, into your lungs. The carbon in your DNA, the stuff that makes up every gene, every instruction that makes you 3 helium atoms had to slam together inside a star to create it. That exact process. Without it, organic chemistry wouldn't exist, life wouldn't exist, you wouldn't exist. You are 13 billion years old. You probably think of yourself as young, maybe a few decades old, but that's not the whole truth. Your atoms, they're ancient, way older than Earth, older than almost anything you can see. Most of the hydrogen in your body, and hydrogen makes up a lot of you, is original. It was made 3 minutes after the Big Bang, and it hasn't changed since. That's 13.8 billion years. You're walking around with the universe's very first atoms inside you. Right now, the heavier stuff in you, the carbon, the nitrogen, the oxygen, the iron that's a bit younger, maybe 8 or 9 billion years old. It was forged inside stars that lived and died before our sun was even born. So here's the truth. You're not brand new. You're a rearrangement. The universe took ancient building blocks and organized them into you. For a little while, the temporary arrangement. And here's the beautiful, bittersweet part. You won't keep these atoms forever. When you die, they'll go back to the earth. They'll become soil, then plants, then animals, then other people. Your atoms are borrowed, on loan from the cosmos. For a few decades, they get to be you, and then they'll be something else. But they'll never disappear. Atoms don't die. They just keep moving, keep changing form. The carbon in you right now might have been in a dinosaur once, or a tree, or in the ocean, or in one of your distant ancestors. And after you're gone, it'll keep going forever. You're a temporary pattern made from permanent pieces. And honestly, that's kind of beautiful. Quarks in the first particles. After inflation, the universe was still insanely hot. Trillions of degrees. Way too hot for normal matter to exist. But something could exist. Quarks. Think of quarks as the building blocks of building blocks. They're what protons and neutrons are made of. And back then, they were swimming around in this super hot soup of pure energy. No structure, no organization, just potential. As the universe kept expanding, it cooled down. And at 1/1,000,000th of a second after the Big Bang, something clicked. Quarks started sticking together. 3 quarks made a proton, 3 different quarks made a neutron. Suddenly, the universe had structure. Not atoms yet, but the pieces that would eventually become atoms. But here's the problem. The universe also made antimatter. For every particle of regular matter, there was a particle of antimatter. And when matter meets antimatter, they destroy each other completely, turn into pure energy. So everything should have cancelled out. The universe should have annihilated itself. Just poof, gone, leaving only energy behind. But that didn't happen, and we don't know why. For every billion particles of antimatter, there were 1,000,000,001 particles of regular matter. One extra, just one out of 1,000,000,000. And that tiny, inexplicable leftover, that's everything. Every galaxy, every planet, every atom in your body. We're the remainder, the cosmic rounding error, and nobody can explain why we survived. 3 minutes. The first nuclei. At 3 minutes after the Big Bang, things had cooled down enough for something new to happen. Nuclear fusion. Protons and neutrons started sticking together. They formed the centers of atoms, what we call nuclei. Hydrogen nuclei were just one proton. Helium nuclei were 2 protons and 2 neutrons. A tiny bit of lithium formed too. This whole process, called Big Bang nucleosynthesis, lasted about 17 minutes. 17 minutes during which the universe created 75% hydrogen and 25% helium. And then it stopped. The universe cooled too much. Fusion needs extreme heat. Without it, no more nuclei could form. So from that point forward, for the next 13 billion years, the universe stayed 75% hydrogen. That ratio got locked in during those 17 minutes when the universe was barely 3 minutes old. But here's the important thing. These weren't atoms yet, just the cores, the nuclei, no electrons attached, because it was still too hot. Any electron that tried to stick would get blasted away instantly by all the radiation flying around. So the universe had the ingredients for atoms, but it couldn't put them together yet. That would take a lot longer. 380,000 years of fog. For 380,000 years, the universe was like being inside a thick fog. It was full of light everywhere, blazing, intense, but you couldn't see anything because the light couldn't travel. It kept bouncing off free electrons endlessly. A photon would go a tiny distance, hit an electron, get absorbed, get spit back out, hit another electron, over and over. Imagine a room where every wall is a mirror and light just bounces around forever, never escaping. That was the universe, glowing but opaque. This period is called the Cosmic Dark Ages, which is kind of funny because it was the opposite of dark. The universe was blazing with light. The light just couldn't go anywhere. And the whole time, the universe kept expanding, cooling, slowly dropping in temperature, getting closer to a critical point. And then, at 380,000 years, something finally happened. Recombination, the birth of atoms. The universe cooled to about 3,000 degrees, still crazy hot, hotter than most stars' surfaces, but cool enough for electrons to finally stick to nuclei without getting immediately ripped off. And boom, atoms formed. Real atoms, hydrogen atoms, helium atoms. Simple, stable, complete. Scientists call this moment recombination, even though that's technically the wrong word. The electrons weren't combining because they'd never been combined before, but the name stuck. And the instant atoms formed, something else happened. The universe became transparent. Why? Because light doesn't interact with complete atoms the same way it does with free electrons. Suddenly, photons could travel freely. For the first time in 380,000 years, light could actually move without getting scattered everywhere. The fog lifted. The universe went from opaque to clear, instantly. And that light, the light that finally got released in that moment, is still out there, still traveling right now. We can detect it. We call it the cosmic microwave background radiation. It's literally the afterglow from the moment atoms were born, the oldest light in existence. You can point a telescope in any direction and there it is, faint, stretched out by billions of years of expansion, but real. It's like a baby photo of the universe when it was 380,000 years old, but still missing the good stuff. The first atoms were just hydrogen and helium, 75% hydrogen, 25% helium, a tiny trace of lithium. That's it. And here's the problem. You can't build anything interesting with just hydrogen and helium. No carbon for organic chemistry, no oxygen to breathe, no iron for blood, no calcium for bones. None of the elements that make life, or really anything complex, possible. The universe had atoms, but it was chemically boring, basic, like having a kitchen with only flour and water. You can't make much. So the universe waited. For 200 million years, it was dark. Not foggy anymore, transparent, but dark. No stars yet, no sources of light. Just enormous clouds of hydrogen drifting through space, cooling, slowly collapsing under their own weight. And then, finally, in pockets scattered across the universe, the first stars turned on, and that changed everything. Atoms are mostly empty space. Here's something wild. You are almost entirely empty space, like 99.9999% empty. An atom's center, where the protons and neutrons live, is incredibly tiny. If you blew up an atom to the size of a football stadium, the nucleus would be like a marble sitting on the 50-yard line, and the electrons, they'd be way up in the seats somewhere. Everything between them, nothing, just empty space. So right now, when you're sitting down, you're not actually touching the chair. The electrons in your body and the electrons in the chair are pushing against each other, like two magnets that repel. You're hovering above it, just barely, but you are. You've never actually touched anything in your entire life. Not really. What you feel is electromagnetic force pushing back, but actual contact never happens. Atoms don't touch. Hydrogen has been here forever. Most of the hydrogen in your body is from the Big Bang. It formed 3 minutes after everything began, and it's been around ever since. Hydrogen is the simplest atom you can make. One proton, one electron, that's it. And the universe made tons of it. So much that even now, after 13 billion years of stars forming and burning, 75% of the universe is still just hydrogen. When you drink water, H2O, the hydrogen in that water is older than Earth, older than galaxies. You're literally drinking atoms that were made at the beginning of time. That's not poetry. That's just what's happening. You replace your atoms every 7 years. Here's something weird about who you are. Almost every atom in your body will be gone in 7 to 10 years, replaced by new atoms from the food you eat, the water you drink, the air you breathe. Your cells are constantly swapping out old atoms for new ones. So the you that exists today is physically made of different atoms than the you from 7 years ago. But here's the strange part. You still feel like the same person. You remember being that person 7 years ago. You feel continuous. But physically, you're made of completely different stuff now. This is an old philosophy question. If you replace every plank of wood on a ship over time, is it still the same ship? If every atom in your body gets replaced, are you still you? People have been arguing about this for thousands of years. And the atoms? They don't care. They just keep cycling through. Atoms are quantum weird. Atoms follow quantum mechanics, which means they act strange in ways that don't make sense based on everyday life. An electron doesn't circle the nucleus like a planet goes around the Sunday. Instead, it exists in a cloud of possibility. It's kind of everywhere at once in that cloud, until you actually look at it. Then it suddenly picks a spot. This isn't a metaphor. This is actually how it works. Tiny particles can be in multiple places at once until you measure them. Then they decide. Atoms can also be entangled. Two atoms, even if they're on opposite sides of the universe, can be linked. If you change one, the other changes instantly, faster than light. Einstein hated this. He called it spooky action at a distance. But it's real. The atoms in your body do this. They exist in this weird quantum state. They're only solid and normal seeming because there are so many of them that all the weirdness averages out. But deep down, you're made of uncertainty, of particles that don't fully decide where they are until something pays attention. Gold came from space. Every bit of gold on Earth came from space. Seriously, all of it. Gold can't form here. Earth doesn't have the right conditions. Gold only gets made when neutron stars collide, these incredibly dense dead stars smashing together, or in certain types of star explosions. And when that happens, the gold gets scattered out into space. When Earth was forming, it gathered up some of that gold. Not much gold is super rare, and most of what Earth did collect sank down into the core when the planet was still molten. The gold we actually mine, that came later. It was delivered by asteroids crashing into Earth. So every wedding ring, every piece of jewelry, every gold circuit in your phone, it all came from stars exploding or colliding billions of years ago. We're literally mining the leftovers from cosmic disasters. Why did the universe bother? Okay, so we've traced the whole story. Big Bang, first particles, first atoms, stars, explosions, heavy elements, Earth, life, you. We know how it happened. Scientists can write out the equations, predict what should form and when. But here's the thing we can't answer. Why? Why did the universe make atoms at all? Why not just stay as pure energy forever? Why go through all this trouble? And why these specific atoms? Why do protons and electrons attract each other in exactly the right way to make stable structures? Why not something completely different? Here's what's really strange. All the forces in the universe, gravity, electromagnetism, the forces that hold atoms together, they're perfectly calibrated for atoms to exist. If gravity were just a tiny bit stronger, stars would burn out too fast. If electromagnetism were a little weaker, electrons wouldn't stick to nuclei. If anything were even slightly different, atoms couldn't form. The universe seems fine-tuned for atoms, for chemistry, for complexity, for life, and nobody knows why. We exist because we can. Some scientists say, well, of course the universe allows atoms. If it didn't, we wouldn't be here asking about it. This is called the anthropic principle. We exist because the universe makes it possible. But that doesn't really explain anything. That's like saying, I'm here because I'm here. Okay, but why? Maybe there are infinite universes out there, a multiverse, and most of them are dead, empty, lifeless. But we happen to be in one of the rare ones that works. Not because ours is special, just because we couldn't exist in the others. Or maybe there's only one universe, this one, and the fact that it works is just luck, coincidence, something else. Honestly, we don't know, and maybe we never will. But the fact that we can even ask the question, the fact that atoms organize themselves into brains that can wonder about their own existence, that's pretty incredible. You are the universe waking up. 13.8 billion years ago, there was nothing. Then there was everything. Chaos. Then slowly, order, atoms, stars, planets, life, you. The universe made atoms from nothing. And those atoms eventually became you, which means you're not separate from the universe. You are the universe. A small piece of it, a brief piece, but a piece nonetheless. You're how the universe experiences itself, how it wonders, how it asks questions. Right now, as you're drifting off to sleep, just remember, the atoms in your body have been on an incredible journey. They were made in exploding stars. They drifted through empty space. They gathered into planets, became water, became life, became you. And when you're gone, they'll keep going. They'll become something else, someone else. The journey never really ends. The atoms are basically immortal. But right now, for this brief moment, they're yours, and you're here, alive, aware, thinking. Rest now. You've traveled so far to be here, across billions of years, through exploding stars and cold, empty space and everything in between. You're home now, and the universe is just grateful, because through you, it gets to experience itself, to feel wonder, to rest, and sleep well, Stardust. The universe will be here in the morning, and so will you.